Well, I warned they were coming and they're here, the unit vectors. So unit vectors is any vector with a magnitude of 1. So its length is only length 1. Now, the most common unit vectors I actually have already mentioned. I, which looks like that, right? Technically it can be anywhere, right? Because vectors are free, this is also I, right? A vector of length 1 that goes in the positive x direction. But the most common way to draw it is in standard position along the positive x-axis. So that's I. And then j, which is a unit vector in the positive y direction. So I is abbreviated several ways, actually, I should say. So because it's so commonly used in so many fields, it has a lot of different ways to write it. So I is also I with a little caret on its head, which is over 1 up 0. J, which again, any vector of length 1 works because they're all the same, right? Because vectors are free. J is J with a little caret on its head, which is 0, 1. Now, to be honest with you, these get used so much that we just abbreviate I and J a lot without actually putting the vector notation over it, but it's implied. Okay, so that's all well and good, but we can actually take any vector and write it as a combination of those unit vectors. This is what I was already showing you. I was just warning you that it was coming. So this is vector v, this is bracket notation, actually, I should say. So that's bracket notation. And then there's the unit vector notation, which is what the question's asking. So you could write that as negative 5i plus 4j. So that's unit vector notation, or coordinate. It's really coordinate unit vector notation. So they say the same thing. They're just two different ways of saying it. All right, now we can also turn vectors into unit vectors. So we can find a unit vector that makes an angle theta with the positive x-axis, where u is that unit vector is equal to the cosine of theta sine theta. And we could find a unit vector in the same direction as the given vector v. So there's two things going on. So we could take a unit vector that makes a particular angle, and we can write it. And then we could also take a vector that we know what the vector v is and change it into a unit vector. Okay, so two skills, and we're going to use them both a lot in this class. It's tons and tons. Okay, so let's start off with this vector here. So we've got 5, 2. So vector 5, 2 over 5 up 2, right? Looks like that. That's vector v. Okay, so we want to find a unit vector. So instead of having it be this length that it is, we want to change it into a smaller vector that's pointing the same direction. So we need to find the magnitude of v for starters. The magnitude of v is the square root, because we're obviously using the second one. We don't have an angle, so we're using the second one. So this is the square root of 5 squared plus 2 squared, which is the square root of 25 plus 4, which is 29. That's 9. Okay, so then the unit vector that's in the same direction as v, and the way we notate that a lot, I should say, is to put a little subscript v next to it. So it's the unit vector in the direction of v, right? It's just the unit vector. But it's in that direction. So the way we notate that is putting a little subscript next to it, is equal to v divided by the magnitude of v. So that would be the vector v, which is 5, 2, and we're going to divide it by the square root of 29, which is our scalar. So that's really 5 over the square root of 29, 2 over the square root of 29. That is the unit vector in the direction of v. Now I'm going to draw it. So It would be, I mean, I could find decimals for it, but suffice to say that it's a little tiny thing in here, right? So that unit vector is in here. That's the unit vector in the direction of v. It's a little piece of the v, and it's only length 1 instead of being length square root of 29. All right, now let's do this one. Find a unit vector at a 40-degree angle to the positive x-axis. Okay. So now we have an angle. This is great. So we're going to be using the angle one. So the unit vector would be a vector that's made out of the cosine of 40 degrees and the sine of 40 degrees. Simple as that. Now, I say it's simple. It's not simple. So if you're working in Desmos, which I often recommend to students for these types of problems because Desmos is really nice with degrees, you just convert. You hit the little wrench over here and you say, I'm in degrees, not radians. And you tell it the cosine of 40 degrees, the sine of 40 degrees, and you're happy, right? You've got a couple numbers. It's a decimal approximation. It's not perfect, but it would work. So you could say, 0.766, comma 0.643 if I was rounding to 3 decimal places. And away we go. Okay, so that's the unit vector from Desmos. Now, with Maple, it's a bit more complicated. Maple doesn't take degrees as a standard rule. So you have to convert your degree measurement of 40 degrees to radians. And the command for that is the convert command. And you tell it 40 and then the word degrees, comma, radians, and then you have it. And then if you want the cosine of 2 pi divided by 9, pi, by the way, you have to capitalize pi if you're going to use it that way. You can also grab it from the palette over here on the left. I just never think to grab it, but it's over there under the common symbols. So I want the cosine of 2 pi over 9, and it just knows that that's that. So that's not helpful. So what if I want that way? I can see that it's the same thing, right? So it doesn't work out to be anything lovely. So we're seeing that. So we're not going to get an exact answer apparently because it's not working out to anything nice like the square root of 3. It's just not going to happen. Sine of pi over 3, same thing, or 2 pi over 9, sorry. There, you can see it's just saying, yep, it's the sine of 2 pi over 9. So that is the exact answer. If you want a decimal approximation, in Maple there's a few ways to do it. You can actually put in a decimal point and it's going to trick it into thinking that it's decimals. And so when you press enter, it should work. There it is, 0.64, just like Desmos came up with. So, but you have to convert to radians first, or you can actually embed, here's fun, you can take this and you can convert it inside that, and then it'll do it, right? So you can say, find the cosine of this angle, but that angle is converted from degrees to radians. There are other ways to do it. As with most things in Maple, there's usually like 7 different ways to do it, but that's the way to do it. So let's make a note. So this is the exact answer. There is no nice square root function or anything else for that. This is the decimal approximation. And we could get the decimal approximation from either Desmos or Maple. It's just more work in Maple. Maple's not as easy on the conversion from degrees to radians.